So if you had to sum up your talk in, let's say, 15 seconds or less and sell someone on it, what would you say?
I would say that React Suspense is going to take care of all of the most annoying parts of building React applications.
Everyone, the encore presentation is about to start. Let's give a warm welcome to Swizec. All
right. Hi, everyone. So, for the record, this is the latest I've ever given a talk, so this might be a little rusty. But we're going to be talking about what's exciting about React 18, where I'm going to show you 2 demos about stuff that I've played around with, and then we're going to look at what's exciting about React 18. A word of warning before we begin is that everything I'm going to show you today is alpha/experimental software. The official timelines that the React team have released are that the React 18 alpha is available right now. You can download it, you can play around with it. They really want everyone, or as many people as possible, to try it, so that they can iron out any bugs and fix any issues. We're going to get a public beta in months, and the RC is going to be on a month's timeline, and then the React 18 official release will be 2 to 4 weeks after the RC. Usually from what the React team, when they say things like this, in the past it's meant that they're probably going to release it sometime this fall or towards the end of this year, unless they run into some really weird issues, which hopefully they won't, because they've been working on concurrent mode and the things that are coming in React 18 since 2018. So they've had a good 3 years. So I'm hoping that they're close to ready. They're ready enough to start announcing it, which is a good sign. So the first demo I'm going to show you is really exciting because it lets you run a, let's see, crap, what did I do? Okay, shit. I had a shortcut on my touch bar and it went away. So I guess the touch bar is not as useful as I thought it was. Sorry, I'm going to have to show you the demo without seeing what I'm doing. So I have this React app here. This is built with React 18, and it was, oh, sorry, I have Flux, and I need to turn that off so it's not orange. Forgot about that. All right, no more orange screen. So if you see, this is a fractal. It's what's called a Pythagoras tree. Right now, it's rendering 255 squares. And the interesting thing here is that all of these squares are recursively nested, which is essentially the worst case scenario for a rendering engine. Anytime anything updates, everything on the screen has to update. So with 255 squares, when I lean the tree, you can see that on a modern laptop, this is pretty fast. It's re-rendering as fast as I'm changing the input values. But now, I'm going to take this part, and I'm going to crank this up all the way to 4 million squares. Because it's recursive, and you saw that React was still able to render it. And now watch what happens to the radar when I try to lean the tree the other way. And also observe what's going on with the input. So I'm all the way to the right, and it's going to jump to the left eventually, and then jump back. And what you're seeing is essentially jank. It forgot that I went the other way as well. So now I'm going to enable React 18 mode. This is still stuck. Well, I'm going to enable React 18 mode when it lets me. So I'm clicking and nothing's happening because it's still trying to catch up with the state updates from before. Let me just reload this because, oh, okay. So it crashed. We were able to crash my browser with 4 million nodes that were trying to update in real time. And remember, this is the worst possible case scenario for a rendering engine. I'm just going to kill the tab and make a new one, because that's going to be easier. Right, so we're back here. We go to 4 million nodes. And when I turn on React 18 mode, watch what happens with the input. The input is still smooth, but this becomes less opaque. It's a little transparent, and then it's going to eventually jump and re-render. There we go. So I'm going to make it a little smaller so you can see what's going on. We're at, hey, why did that not re-render? That's okay. Well, there we go. 1 million squares, but now I can smoothly move the lean, and the tree catches up eventually. So what's interesting here is that this is not using any userland hacks. There's no performance optimizations that I made. I just naively render 2 million nodes on every state update, and React deals with the rest and makes sure that my input stays responsive while everything else catches up later. So that's the first demo I had. The other demo I wanted to show you, let's see. The other demo is, I didn't know what to name it, and I couldn't find a good screenshot, and it's not going to be as exciting as that one, but it's going to show you another interesting thing. So this one is built-in code sandbox, so it's going to be a little less fancy, and you can see that we're basically, it's showing you bestsellers from New York Times. Both sides are making an API request to New York Times to get a list of bestseller lists, then taking the first list and making a subsequent API request to get the actual list of books. The only difference you can see is that this one renders with one spinner, and this one has a spinner for the first API call and then a spinner for the second API call, which isn't very exciting until a little later when I show you what's actually going on here. So what is my next slide? So as you saw, none of this was the demo with a lot of nodes is cool, but you could do that before. You could use userland hacks. You could use what they call it, time slicing. You can do loading spinners right now. It's not a big deal. We can already do all of this. Like I said, you can use set timeout to delay some transitions. You can debounce your inputs. You can deal with loading spinners and whatnot. What's different is how we got there. All of this, if you want to do it right now, is a lot of extra fiddly work that you have to get right every time you do it. And especially if you've ever worked on a larger team and you're the person who's preparing frameworks, who's preparing tools for other engineers to use, it's very hard to be in everyone's PRs and make sure, hey, you forgot that little edge case in your code, or hey, you forgot to add a spinner here, what if this data is not ready yet? Or my favorite, hey, this went to production, but when you reload the page, it crashes because the data isn't in cache yet. It only works if you click on the link. That's not good. So what's new in React 18 is that we're going to have a new way of solving all of these problems that essentially boils down to React Suspense, which is the thing that they've been promising since forever, basically, I think 3 years now. We have two types of suspense. They're calling it two types of suspense. We're going to get suspense for high CPU, for heavy renders or re-renders. That's coming in version 18. Suspense for data fetching is coming in 18.x. You can play with it now in experimental mode, but it's not going to be ready for the alpha. And they have something called streaming partial hydration that's coming also in 18.0. That's the one I don't have a demo of, but I will talk about it anyway. So the main thing that they've changed is that the whole way of how React works is now different. You have asynchronous subtrees. What that means is that you create a tree of React nodes, and it's the same as right now. you have these nodes. They're children of children. They re-render when you change state. They re-render when basically whenever React touches them. Everything stays the same. The difference is that React can now asynchronously hold, essentially, it's almost like splitting your brain in half. It can automatically deal with a part of your tree rendering later or being rendered later. You trigger one re-render event or one thing. I don't know the official word for what they call it, but you basically change some state, and React can say, oh, this state is changing slower. We're going to render that part of the tree later when it's ready, but we can handle this difference. We can handle essentially, it's like tearing in a video game where you have a part of the screen that's out of sync with the rest of the screen. React now supports that as the primary way of dealing with asynchronous states, dealing with slow transitions, and all of that stuff. So like I said, it's built on two types of suspense. First, you have the suspense for high-load CPU for slow subtrees, and then you have suspense for data fetching. And all of this is also supported during server-side rendering so that you can then deal with partial hydration, which we'll talk about in a bit. So suspense for CPU for high CPU subtrees is coming in alpha, which is going to be whenever it's ready. And I'll show you in the demo exactly how this works. The main idea is that you can take a part of your state updates and you say, you know what, this update is not as critical as the other updates. You can handle this one later whenever the tree is done rendering. So you trigger the state transition now, and then React renders that whole subtree in memory, and when it's ready, flushes it to the screen, which is what you see in the demo here. I'll show you the demo again. So this demo here, what's happening is that when I move this, React is immediately re-rendering the input field, which is a controlled input, and then it's scheduling it's waiting to render the tree itself until it's ready in memory. When it's already rendered in memory, then it gets flushed to the DOM. And the nice thing about that is that, oh, did I crash it again? Okay, that's not supposed to happen. But the cool thing when this doesn't crash on my computer, so in reality, I hope nobody actually is re-rendering 2 million plus nodes on every input change. But the idea is that you can make it wait. And also one problem, so the problem with userland hacks for this sort of thing is that they often you run into edge cases, whereas here, when I move this thing a lot, React internally handles throwing away states that are no longer valid. So we change the state, and then we change the state again, but the tree wasn't re-rendered yet. React says, oh, wait, I don't actually need this update anymore. I'm just going to throw it out and not bother with it. Whereas if you're using delays or weird hacks, you're re-rendering every time, and you get weird effects where it's kind of like speeding up and catching up with you. So I'm going to show you exactly how this works. Let me zoom this in a little. It's going to be, okay, I'm going to be looking away from you because I can't figure out how to mirror my screen anymore now that the touch bar went away. But so first of all, to opt into React, you're going to have to change how you, let me zoom this in a little bit more. So the first thing you do to opt into React 18 is to change how you render a part of your tree. Instead, it used to be React DOM render, and then you gave it an HTML node and what you want to render. Now, instead of that, you create a root element and then render an app or something into that tree. The nice thing about this is that you don't have to opt into React 18 on your entire code base. You can opt into sections of your code base, and it works side by side, and it should be fine. And I'm also really excited that backwards compatibility on React 18 is kind of amazing. I took this fractals project that I last touched 2 or 3 years ago, installed React 18, opted in with this new root rendering approach, and it just worked. I didn't have to change anything else. It supports class-based components, supports hooks. Basically, code just works, so I didn't notice any bugs. Officially, they say that they aim to make sure that any application can be updated in about an afternoon. So if you take an afternoon of somebody's time, they can probably update your entire stack to React 18, which you don't have to start using any of the new features. Everything still works, but you can start using it, and then you have the ability for where you need it. So the actual rendering, let's see. So here I put everything in the app because I'm lazy. Let's see. So this is the one where I'm using React 18 state transitions. So you're going to see this a lot. The combination of functions that you used for this effect is start transition and use transition. That doesn't mean it has anything to do with CSS transitions or visual transitions. It's meant to be a state transition. And the reason it's called a transition is because it doesn't happen synchronously at the same time as all of the other updates, but it's letting React transition that everything that depends on that state that you're transitioning over time instead of immediately. And don't worry, I'll show you how it works. So we have two combinations of state. Usually what you've seen in production React code is that you have the input field, a controlled input field that renders from a piece of state, and then everything that relies on that state uses the same state value. That works right now, and it would still work in React 18, but it means you can't use transitions because you need to tell React, hey, you need to split the state into two so that you can use it separately for the critical part and for the non-critical part of your UI. And then we have use transition, which is what we use to render the tree as more transparent while it's transitioning, so that the user also knows, oh hey, there's something going on here, and they can wait and so it doesn't just look stuck. They can see, oh, something's happening, and I'm sure that as the patterns for this advance, you could probably render a spinner, or you could figure something out that tells the user that something's going on here and they just need to wait a little bit. And then we have the change tree lean. This is an input change handler. This gets called all the way down here where I have a slider. Where's the slider? Lean tree. So you see on change we call change tree lean, and we use tree lean input as the value for the input, which makes this a controlled input. And then on change tree lean, first we get the value from the input, and then we instantly re-render the input itself. We update the value that's rendered on the input, and that instantly re-renders that component, and also triggers a re-render of the whole tree, of the whole React tree. And then we call start leaning. Is that what I call the transition? Yes. So use transition. Start leaning is what starts the transition to. You can do either React start transition and then change the value, or you can use the use transition hook, and then you have a function that's similar to use state. You have the current, whether true or false, whether it's currently transitioning, and then a state update that actually re-renders that updates the state for the component that's less critical. So what's happening here is that we took state that both components were relying on, split it into two different state values, and then we said this one is less critical using the transition, and then React handles all of the delays for us. While this may look like async code, from a user perspective, it's not async. All of this happens at the same time from a React user perspective, which I think is going to take some getting used to, because we're used to thinking about, oh, this is a delayed transition, so I have to handle it as being asynchronous. I have to think about that. You don't. React handles all of that for you on its own. And that's going to be kind of the mind-blowing thing, especially when we go into the next example. So this is how you use state transitions primarily for high CPU, for things that are slow. You don't have, for actual data loading, we have a similar but slightly different approach. This is what people always called React Suspense. And this one's not ready yet. This one will be coming in 18.x, but you can use it with experimental flags. And they've been working on it for a while, and it's going to also improve our lives, I hope. And I'm going to show you how. So the main thing about this React Suspense is that, similar as before, React is handling loading states for us. It's also coordinating queries between each other. That's why we are able to have only one loading spinner instead of two loading spinners. And if you look carefully at this code snippet, it's fetching data from an API, but there is no async await anywhere and no promises in userland code. And when that clicked, when I was playing around with it, my mind was kind of blown. How is this even possible? And I have some ideas how it's possible, but I think that's why it took 3 years to get here. So let me show you first, again, if I reload this page, you see two loading spinners. This one loads. This one has a spinner cascade because you load the component, the component says, oh, I need data, goes to the API, shows a spinner, gets the API, renders the next component, and then the next component says, oh, wait, shit, I also need data, and shows the next spinner. And you get this cascade, whereas with Suspense, it's all coordinated and you get just one loading state, which, depending on what your users are like, depending on your actual needs, may be better or worse. I think it's usually better, but who knows. So let me zoom this in a little bit as well. So I'm going to show you first, real quick, how this works without Suspense. So without Suspense, you would use, we're using a normal fetch API. You have an async function that fetches a list of books, calls await fetch, then awaits parsing the JSON, and returns the results. And we have the same thing for both lists and books. Then I have essentially wrong one. And then I have a poor man's implementation of React Query. You would have something similar with GraphQL, and I'm sure that most of us have built code that looks a lot like this. You have some state that says whether you're currently loading from an API. Then you have some state that has the result of the API call, and you'll call a use effect on component mount. In that use effect, you say, OK, we're now loading. Then you have some sort of async await or a promise that goes to the fetch API, fetches the data, sets data to the state, and says we're no longer loading, and you kind of return loading state or end the data from your component, from your hook. And then when you're actually using that, it kind of looks like this mess. You have a component and you say, OK, I need the loading state and I need the actual data. If we're currently loading or something went wrong, we're going to show a spinner. If we have everything we need, we iterate through the data and we render what the component is supposed to render. And this is fine. It becomes very mechanical. I can probably write this in my sleep by now, and I'm sure most of you can as well, which means it's tedious and boring and nobody wants to do it. But you just kind of have to do it everywhere in your app. Anytime you use any of these data fetching hooks, oh shit, I need a loading state, I need this, I need that, I need error handling. It's boring, it sucks. And I don't want to deal with this every time I'm doing anything. So with Suspense, all of this becomes a lot easier. I used the, wrong one. So I used the React fetch library that the React team is working on. I don't know if they're officially working on it or not. The version of React fetch that's on NPM is like version 009 from some random dude. And then it has a bazillion experimental releases from the React team. So I don't know what's going on there, but I think the idea is to just show what's possible and how to implement it. And the hope is that libraries like React Query and Axios hooks and all of those data fetching libraries that everyone likes to use are going to implement this. And React Fetch is kind of like a demo version of how to do it. So the main thing you might notice here is that I have a fetching function that is not async. It's a normal function that calls fetch, which is not awaited. It's just a fetch call with no promises. And I'm parsing the JSON. Again, no await, no promises, nothing. It's just a function that calls an API and casually returns the data. No async or anything anywhere. I am making sure, though, that I throw an error when an error happens. That part is actually important. And now when you're using this, the main component wraps everything else in Suspense and says, hey, this part of the tree is going to be asynchronous and it's going to be loading some data and doing stuff. So while this tree is waiting to be rendered, or one metaphor I've heard is that it's like the child component says, halt, I'm not ready to be rendered yet. So Suspense says, OK, you're not ready to be rendered. I'm just going to show the fallback component in the meantime and wait until you're ready, and then I'm going to render you. So I have a spinner here as the fallback. You could have the current state is one approach, or something I've played around with a while ago is you could have question?
Just out of curiosity, I suspect it's not just the children, it's like any descendants.
Yes.
That needs to be rendered.
Yeah. So, yeah.
Anyone.
You said the question back.
Oh, so the question was whether it's the immediate children of the Suspense component that can halt rendering, or any descendant. Any descendant in the entire tree can say halt, and the whole tree will stop rendering and show the fallback component. An idea I've toyed around with, but Suspense wasn't ready yet then, is this could work with server-side rendering very well, or with Jamstack, because you have static data that's available at compile time, and you could show that in your fallback while you're rendering the fresh data from the API. That would be cool. But for the demo, we're just showing spinners. So the spinner then, so the Suspense component renders content, and then you have content, which is a book list. Now notice this is a normal React component, and it's just saying, list is fetch book lists, take the first one. There's no async, there's no await. I'm not doing any promises. I'm just saying get data from an API and start using it immediately. And when I'm rendering that data, there's also absolutely no consideration that this data may be unavailable or that it may take some time to get this data. I'm just using it as if it's always there. And we render the book list as well. We only render the book list once this fetch API is complete. Notice no loading states, no dealing about that. And then the book list is the next one that says, whoa, whoa, whoa. I know you rendered me. I know I got my prop, but I'm not ready yet. And the entire tree is not being rendered while that's happening. And then this fetches data, again, no async, no anything, and very naively goes through the list and renders the whole thing. The cool thing about this is that because the whole subtree, anything in the subtree can say halt, that also affects any, so if I had a sibling element here, right? So let's say this is a sibling component, which I don't currently have, but this sibling component would also not be rendered, and all of its effects, like on-mount effects or layout effects or any of that, would wait until the entire suspended subtree is ready to render and then run. I don't know yet what that would be super useful for, but it's pretty exciting. So that's Suspense for data loading. This is the one that everyone's been talking about and waiting for a long time. And it's going to take a little longer for them to handle. The nice thing here is that it comes with a built-in cache component. So you've probably, if you've used React Query or Apollo, you know that we like to cache data on the front end so that it doesn't have to be refetched all the time, especially if you have different components rendering from the same data at different times. You can take it from the cache. That is now going to be built into React by default. So if you use a Suspense-enabled library, it's just going to work. You can make those API calls anywhere, not even think of them as API calls. It's just data that once it's ready, and your component renders. And it might, when I first heard that, I was just like everyone here, like, yeah, that's kind of cool, that's cool. But then when you try it, it's like, oh my God, this is so different than anything I've ever had to deal with in React so far. And it literally feels like magic. So I encourage everyone to try it out. I have some blogs out that explain it in even more detail than what I've talked about here. To be honest, I don't exactly know how the Suspense for fetch works. I need to dig into it, but one explanation I've read on so I read this in a Reddit comment that was in response to me being mind blown about how it works. So I'm pretty sure it's correct, but I haven't personally verified it. And they said that what React Fetch is doing is that it's throwing a promise. So instead of returning the promise, it's throwing it, which then enables the Suspense component to catch that throw, to catch that error, and wait for the promise before it renders everything else. So it's kind of like a combination of an error boundary and what the error boundary is catching, which I guess means you could theoretically do this yourself right now with error boundaries, but I wouldn't recommend doing that. So those are the two main ways that Suspense works. Now, the part of Suspense that I haven't played around with yet is Suspense for hydration, which is also coming in version 18.0. And the important part here is that Suspense is going to be fully supported for server-side rendering, which means that you can render your React tree on the server, same as you are now, like if you're using Next.js or Gatsby, or you hand-rolled your own framework for it. You can render it on the server, and it's going to be able to suspend parts of the tree and render them later. And it's also going to support that in hydration. So when you load your page, so with the Jamstack, what we usually do is make a static version of the page, load it into the browser as HTML, and then rehydrate that with React, and it becomes a React app. That is, especially if you have long pages like I do, that is killer for your time to interactive metrics, because Lighthouse is annoying like that. And even though it's interactive as HTML, they wait until it becomes interactive as JavaScript, and then they say that it's interactive, which is okay, except that this now impacts your SEO scores, and they are very strict about it. So with Suspense for hydration, and I don't know if it's actually called Suspense for hydration. They're calling it partial hydration, but it's very similar, so I decided to call it the same thing. You're going to be able to hydrate parts of your application in advance. So you're going to be able to say everything above the fold needs to be hydrated immediately, and then you can deal with hydrating the rest of the app that's less critical, which means that you get faster time to responsive, you get faster time to interactive, better Lighthouse scores, and by extension, better SEO, and hopefully happier users. I don't think I've ever in the wild actually been able to observe hydration being slow, but my Lighthouse metrics have definitely noticed. Yeah, so that's the main thing that I want you to take away from today's talk, is that React 18 is going to be super exciting. I can't wait for it to be ready. I hope you all go and play with it and try it out. It's going to be pretty easy to adopt into your existing apps without much fuss, and then you can opt into React 18 features when you need them, when it makes sense. And fundamentally, it means that we're going to have asynchronous React trees that are going to be able to resolve before the rest of the tree is ready. So one React component tree, different render times, and kind of just sliced apart, and React handles most of the fiddly details for you. Yeah, so if anyone has any questions, I'm here. Question, yes. Okay.
Very interesting talk. Two questions. You mentioned vsync and screen tear. Which is the default for the new Suspense model?
So the question was about vsync and screen tear. The default is that in theory there wouldn't be any screen tear. What may happen is if you're very quickly firing state updates that are so if you're very quickly firing state updates and you're overrunning the render time, you may get portions of your app that are rendered incorrectly. So the example that they use in the work group is if you're, let's say you're rendering 5 different blue circles, and you say that half of them are less important than the other half, and you fire a state update from blue to red while that transition is happening, the new circles may render red while the old ones stay blue. Just because for a split second you have a part of the tree that rendered sooner than the rest. But most of the time this wouldn't really be noticeable in the wild, I think.
And the other question is, use transitioning and start transition. Is there some way to know, maybe I want to have a callback when the transition has finished? There's some, or is that irrelevant in this model?
Okay, so question was if you want the difference between use transition and start transition, and if you can have a callback to when the transition is ended. So React start transition is the underlying mechanism for doing Suspense for high CPU loads. It lets you say that a state update is less important and can be delayed until it's ready. Use transition is a hook that is probably going to be the main way people use this, and it's the same as use state. It returns whether you're currently transitioning and a way to actually fire off that transition. So you can, as far as knowing when the transition ends, you have the Boolean field, the Boolean value that changes from true to false. So usually the target component would use that as a prop to decide how to render. So in the example, in the demo that I used, that's how, where is the demo that I used? So in this demo, that's how the tree becomes slightly more transparent while it's rendering, is because it's listening to that Boolean as a prop. I can't make it happen right now. You could then, if you really need it as a callback, you could have a use effect that runs when that changes. Anyone else?
You had mentioned that there's a caching. How does that play into like the caching that you might get from like React query?
All right. So question about caching for Suspense for data fetch. I don't know exactly how that caching works and how it relates to something like React Query. They're building a cache component, which I think is caching all of the thrown promises for data fetching and caching the results, mostly so that it can coordinate and see, oh, if you've already done this one, we can just get the result. We don't have to wait for the full promise. And I think what they're hoping is that library authors are going to implement that into their caching strategy. I know that React Query specifically already has a Suspense mode. They're still dealing with some bugs and little tricky things because the API keeps changing. But they shared some demos on my Twitter where they have React Query integrated with Suspense relatively. Yeah, it's basically the same, except instead of handling your own loading states, you use React Query, and then it deals with it integrates with Suspense. But I haven't dug into the details of how they integrate the caching. Yep.
Do you think that this will eliminate the need for like techniques like windowing in React?
Question is whether this will eliminate the need for windowing. I don't think it's going to fully eliminate the need for windowing. It depends on what your use case is, I think, because transitions like this can be so scrolling is very interactive with the actual element that you're scrolling, so you would probably still want that to be fast. It would feel weird if it stops for a couple of seconds and then jumps to the next position. So I think you would still need windowing for that. But if you have some way of splitting the interaction of scroll or the interaction of... I think one way you could probably use this instead of windowing is if you knew exactly how many elements are rendered in the visual part of the screen, you could then render the rest of them with a start transition so that they load later. I think, but I would have to play with it. I think it might lead to weird UX. Yeah. All right, then thank you all for coming.
Give it up for Swizec.